Good afternoon, everybody. Give this a couple more seconds for any stragglers to make their way through the lobby. But yeah, welcome to this afternoon session. It's called Apex Analytics. It's essentially about data and motorsports. I guess quick disclaimer before we get started here, kind of like the lock picking session yesterday. This is a more interactive session, so you're not locked down to just the Q&A chat feature of the platform. You can turn on your cameras or unmute yourself at times if you care to interject. We welcome any and all questions, insights, or I guess additional things you want us to double click down on. So, feel free to take advantage of that during this talk. All righty. All right, for those just joining us, good afternoon. This is a talk called Apex Analytics. It's about data and motorsports. Uh, Quick overview of our agenda here. Today, we're going to kind of go over an introduction of not only ourselves, but technology and the area that we will be discussing today. Also, challenges that we faced kind of during the development, implementation, and testing of the solution. We're going to talk a little bit about the Splunk Edge Hub device, again, dive more deeply into our development process around the hardware and software. Then we're going to do a little bit of a demonstration on some tech and hardware that's more, I guess, consumer centric or easier for people to access that really mimics the same type of hardware that the Splunk Edge Hub has in more simple form factor. We're going to do some hopefully live demos about the telemetry and data analytics behind some of the insights that we're seeing from the product. And we're going to talk a little bit about what our plans are for the future moving forward and kind of open up the doors for any questions that you may have regarding what we've done, what we're doing in the future, or anything in between. So, high level about this talk, obviously, we're going to be talking about how we've integrated the Splunk Edge Hub device, specifically into rally racing. We're going to go through our journey, trials, tribulations, and all the like, because this was a very fun, interesting, and challenge-filled experience for us. So there will be some live demos. So please work with us through those, as we know how live demos go. But no, really excited to kind of get started here. And I guess I'll start by introducing myself. I'm John Owen. I'm the Director of Security Analytics here at Fulcrum. On the side, I'm also the Executive Director of Next Gen Cyber Ed, a cybersecurity education association meant for supporting teachers and students in the K through 12 industry. A little bit about my expertise of data analytics, SIM, SOAR, security operations, and kind of everything surrounding it. And I'm pleased to be joined by a member of the security analytics team, Ajay Patel.
Yeah, hi everyone. I'm AJ. I'm a security consultant for Fulcrum. I work under John. On the side, I like to drive a lot, so I do a bit of drifting, a bit of road racing. Also instruct for our local Porsche Club chapter. As far as expertise, pretty much all things security, as far as data analytics, threat hunting, like red team stuff, automation, a lot of coding, containers, things like that.
Awesome. Thanks, AJ. So I guess diving straight in. Challenges that we encountered during, I guess, the development of the solution. Again, this specifically targeted rally racing. We'll go into a little bit of, I guess, the alternative motorsports that we've also done some development in. But if you're familiar with rally racing, it is not the most hospitable environment. These are typically hot conditions with not only dust, but fluids, high temperatures, really just not great for a computer or hardware. We also have things like space constraints because obviously, like these cars may be stripped out and might not have back seats, but there's not ready-made places. The manufacturers weren't necessarily thinking of us putting these devices in the cars when they were building them, or at least the rally engineering teams were actually building those cars. We also had challenges around real-time data. These cars are driving and don't have a power cord or anything attached from a data perspective. But we needed to see if we could get real-time insights so that we wouldn't have to essentially fall into the same challenge that current teams have with having to do a drive, then plug in a data logger, a laptop in, download the data, then analyze the data. We wanted to be able to do this in real time and be able to react in real time to provide the best input for drivers and teams and not have to actually wait till after the race or you actually stop the progress there. Again, these cars are not connected to external power, so we had the limitations of the power of the vehicle, and machines take power, so we had to actually do some interesting things to actually solve the power problem. So, kind of a key component that we used, and I've hinted at it kind of directly, was a Splunk Edge Hub. This is a new hardware device developed by Splunk. I know some of you are thinking, what, Splunk has hardware? Yes, Splunk has hardware. We were one of the first, I guess, handful of partners for Splunk for the Edge Hub platform. This is a hardware device that is built with internal sensors as well as its own operating system. You can also connect it to Wi-Fi, Ethernet, cellular. It also has an I2C port so that you can feed in additional data sensors as well. It also has native compatibility for different protocols like MQTT and SMP so that you can feed it data. And it also has a neural chip on it, which is pretty interesting. So you can do machine learning at the edge. What this platform enabled us to do was have a very modular, supported environment for us to actually do some development on. We wouldn't have to cobble together off-the-shelf hardware that may not be one-to-one compatible with things. This was very much plug and play and fairly easy to integrate, especially for such a new platform. Some key functions it had, it's got an IP66 rating. What that means is it's completely dust tight. It also offers protection against particles, oil, and non-corrosive materials. It also has a high level protection from water, including splashes, sprays, and direct jets at it. Obviously, beneficial for any sort of potentially adverse environment and harsh conditions you may put this thing in. In addition to all of the onboard capabilities that it has, we added a couple things, including a custom 3D printed case that we designed to have active cooling in it and a portable battery. That's what went done, I guess, go in more detail and solved our power problem. This is a kind of an overview outline of the process that we used to actually develop the solution. So obviously starting in prototyping and testing, Ajay is going to dive into that next. Then we actually had to figure out how we would integrate the hardware, how we would integrate the software and get the analytics, how that kind of combined itself into the actual in-car situation. And then how we kind of test, tune, and refine that to actually be something that we can operate off of. Ajay, I'll hand it over to you.
Yeah, so with prototyping and testing, initially I wanted to kind of jump in straight with the Edge Hub device. That didn't quite work out. I had to do some like back and forth stuff with the Splunk engineers, which they were pretty helpful, but going back and forth in email takes a little bit of time. So while I was kind of dealing with that to get things to work, I ended up starting with the Raspberry Pi, taking a Elm 327 OBD2 dongle to plug into my E36M3 for testing and developing the code. The code wasn't super complicated. It basically just used the Python OBD library and the MQTT library to be able to send the data that we were collecting to Splunk. And I kind of wrote the code as efficiently as I could so that I could eventually put all that code into a Docker container that we would eventually run on the Edge Hub. As far as testing, much to my neighbor's annoyance, testing it on the M3 in my driveway. We kind of learned some things like as far as heat management. I was doing it earlier this year. Temperatures were high 90s here in Texas, and just sitting in the driveway, the devices, both the Raspberry Pi and the Edge Hub, when I eventually migrated over to that, were getting pretty warm. And when you're in a car on track, those temperatures skyrocket quite a bit, even with the air moving through. So that was kind of a hurdle that we ended up having to um, develop around.
Nice. So, I guess moving into the actual hardware integration, after AJ was able to get essentially a working product from a software level, we had to figure out how we would actually get that put into a car, have it move around, and really almost be like a wireless solution, so to speak. So, first thing we had to do was get it. I mean, we kind of have, I guess, had a modular approach to this. We knew that we wanted to be able to take this and put it into, many different types of cars. At the time, we had an idea of the type of car we'd be able to put it into, but obviously didn't want to be limited to that. So what we did is we actually developed in CAD and 3D printed a custom case for the Edge Hub. It was effectively two primary pieces. It was an outside shell. You can kind of see it here in red, and then a divider in between. You can kind of see in black. And what that divider did was actually separate the Edge Hub itself from an external battery that we had on the bottom. And so what we put the edge hub on top, it kind of sandwich in between battery on bottom, and we're able to run cables between them. Obviously, this is very, very early in the development stage, so not even everything was self-contained because we had to have as much moving air through this piece of this case as possible because the edge hub is passively cooled. So it's effectively has a big, I can almost kind of show you here on the bottom, almost like radiator fins. There's no fan or anything actually on this device. So if you sandwich anything on it, you're just essentially keeping all the heat in. And so we didn't want to actually add that layer of insulation there. So the divider in between it is hollow. All of it is printed in carbon fiber. So because we knew it was going to be bouncing around a lot and needed to be fairly tough and rigid. So we started from a tough box design, cut a bunch of air holes in it and holes for routing power and cables and sensors and stuff that we'd need to plug in. And then kind of bundled that unit all together. And eventually, you can see on the right side, that was a couple of our installs into different vehicles. So one, we're able to actually strap into the back seat divider, almost like armrest that would flip down. This thing does have gyroscopic sensors in it. And so being able to actually central locate it in the vehicle, either as I guess as vertically as possible or as horizontally as possible in any orientation, would give us better data. And so that was one of the ones, and the other one actually didn't have that. We ended up having to kind of strap it down into the almost footwell in the middle of, I guess right above the transmission or drivetrain tunnel there. You can kind of see the OBD plugs that we had off of it and a couple of sensors that we ran out. I guess kind of shown here, one of the sensors that comes with the device is an I2C connector here. This one does temperature and humidity. So what we were able to do is that, well, I guess more than that, it also does volatile organic compounds, gases and CO2 also. So we're able to run that up and actually kind of get environmental data on what the driver experience would be like. Interesting tidbit that we found is, and one of, and actually one the Fulcrum rally car that we were doing some testing on, it runs on race fuel. And as soon as we started running that car, the volatile organic compound essentially maxed out the sensor because of all the fumes that were in the car. So it was a good test to kind of show some of the, conditions that drivers go through, not only, that, but temperature and humidity that we're kind of tracking for that. Kind of breaking down this so you can kind of see some of the initial development photos, some of the, I guess, custom circuitry that we put in there is essentially just USB powered via USB-C to a couple fans in the back that shot air under the edge hub, under those fins. And so it would just push it from back to front through there. We did a bunch of testing on the effectiveness of the cooling, and even outside in, above 100 Texas heat, we were able to keep this thing cooled at about a 17-degree delta. That's 17 degrees lower than ambient temperature, which was actually perfect. I guess it worked out for us in running temperatures for this thing, even though the internals can run much hotter. We wanted to keep it as cool as possible. The orange here you can see on the fins here, that was actually for helping to cool the battery from the bottom, since the batteries expending electricity do heat up. And that orange is a mock-up. Since we're doing development, we had measured the battery, didn't have the battery, so that I could do things while AJ was running on track. And so I just mocked up the battery and actually 3D printed a mock battery so we can make sure that clearances and everything work just fine. But yeah, Edge Hub kind of sat here up the front, and we use cellular, and then Wi-Fi as a backup. Luckily, the track, I guess the rally track that we were testing at had full Wi-Fi through the whole entire thing, so we're actually luckily enough to leverage that. AJ has some experience testing the cellular at tracks that are not fully Wi-Fi enabled. It's a little bit hit and miss, but that's how it goes. But we're able to get that wireless data straight from the vehicle itself directly onto something like an iPad. So we were running Splunk dashboards on an iPad, essentially in the pit, so to speak. So as the car is going on track, we could see all the telemetry, very, very quickly after it was generated. Hey, do you want to talk a little bit about what our, I guess, path forward was for sensors and data we were collecting?
Yeah, so as far as data collection, I kind of approached it from the standpoint of, a driver that and what I want to keep an eye on and what I would like to know over time from my car while it's on track. So we were pulling data that was available from the ECU via OBD2, stuff like the RPM, the speed, coolant temp, intake air temp, uh, timing advance, oil temperatures, oil pressure, and just general things like that, stuff that we can kind of track over time with the idea of being able to like monitor the health of the engine and kind of get an idea of like how the car is doing and kind of use that for other analytics after the fact, to kind of analyze your drive around the track and what the car is doing, like say in some high speed corners with a lot of G forces. And then as far as placement, we kind of went around with a few different things, given we were testing on a few different cars. One of the things to keep in mind is you have to run this big OBD dongle up to a plug that's generally under the dash near the driver. And so you have to be careful about where we're routing the cable so your feet don't get tangled up in the cord while you're trying to, clutch brake gas. And then placement of the actual Edge Hub device and the battery and everything. We had to place that, keeping in mind like what kind of forces these cars are going through when they're turning or sliding through a corner, or getting on the gas or braking hard, and making sure that if you have a hard brake, you're not going to like launch this thing through your windshield, and also keeping it away from heat. When you're in a stripped out race car, you take out, stuff like the sound deadening and the carpet and all these things that are insulating the heat from the exhaust into the cabin. So you don't want to put it right on the floorboard, right under above where the exhaust is running. So it was kind of tricky to get it figured out, but we when we were testing it out at the Rally Ready place, we came prepared for a bunch of different mounting scenarios and found things to make it work in whatever car we were doing it with.
Yeah, it's definitely experience. You can see through some of these images. This is one of the test cars we worked with. This is the Fulcrum rally car. You can see on the right side that's, for those of you not familiar, that's what the inside of some race cars look like, is a lot of things not in the place that they're supposed to be. A lot of things missing or replaced. There's fire extinguishers, a lot of open cables, kind of, and something like this, and like no AC, very, very much controlled environment. A little bit of it's for weight, a lot of it's for just the handling and effectiveness of the vehicle itself. So, I guess to specifics on the Splunk Edge Hub platform. So, here's some of the environmental stats or specifications for the Splunk Edge Hub device in a non-operating and operating fashion. So, you can see the amount of vibration that it can actually take before impacting any of the internals. Also, the temperature. So, well over 140, 50 degrees Fahrenheit that can be able to take from an operating temperature perspective, which is great. Very, very resilient to humidity, and there's that IP66 rating as well. It is the highest rating for IP6. I guess IP6 is the highest rating that they have for that particular thing. So very much happen to be fit for some of the most of the features that we're looking at here. So software development came in a couple of, I guess, different tranches. AJ, would you like to speak a little bit about, I guess, more detail about the script placement and how that actually functioned in interaction with the Edge Hub?
Yeah. So basically when I was writing the script, I quickly found out that, I mean, it's easy enough to pull data from your ECU, given the OBD Python library. However, pulling all of that data in real time turned out to be a bit of a challenge. But playing around with the code and some of the available libraries, I was able to utilize an asynchronous connection, which allowed me to pull all of those data points I mentioned earlier and basically create one message to send, um, basically one message per second of all that data that was being collected. Um, I was able to pack all that together into a Docker file to load on the Edge Hub so that we could set it up to where when you turn the Edge Hub on, it'll connect, turn the Edge Hub on, plug in the OBD2 to the Edge Hub, and then it will connect with the ECU and start pulling the data from that and sending it via the MQTT protocol to Splunk. Um, we tried to make it as compact as possible and lightweight as possible so that it would start up and run as efficiently as possible. Back to you.
Yep, and one thing that was noted on the previous slide is you can run containers on the Edge Hub itself. So all this was packaged up inside of a local running Docker container, so that actually you did all the code executed remotely on the device itself. So once we did that, and once AJ was able to load the code onto it, it was pretty easy to just turn on the device and let it run. Um, I just hinted at some of the specific telemetry metrics that we're interested in. I guess little short demo of the device. This is the Splunk Edge Hub, and kind of see these are different sensors and the values for each of the sensors that it's collecting from. This will show you all of the built-in sensors as well as any attached or that are being collected. Interesting things like on the right side here, you can actually see the trail of MQTT data that is going to get filtered out here. I'll put it in front of my face. As well as the inbound sensors and external ones that we have here. This does have, like I mentioned, the neural chip in it, so you can develop and push machine learning models out to be essentially watching each individual sensor, and the things will change color as the alerts are fired for things that are anomalous or out of bounds based on your algorithm. And so you actually get a visual indicator as well as I guess, a data telemetry event that's sent when those boundaries are crossed. So really awesome that you're able to do that with these devices, and definitely helpful for us for onboard diagnostics as well as being able to do some validation here. The output of that and outcome is effectively a couple different dashboards that we developed to do this and support insights into racing as well as our developmental processes. One of those was we had a whole entire dashboard that was purely focused on looking at temperature. And so we noticed that fairly upfront that was going to be our biggest struggle. We knew that between the case and the environment and then the device specifications itself and through some testing and interaction with the vendor, things like dust, humidity, water and fluids weren't going to be a big problem for us, even the day or two that it rained when we were out at the track. but we were able to, between AJ having this thing out at his garage and mine at my house here, we would set it out and just basically let it go, sitting out, first in the shade, I guess, well, first in my office, then in the workshop, in the garage, and just start upping the threshold, so to speak, of the environmental, uh, well, the environment that it was in, and eventually just set it outside in direct sunlight, inside the case and outside the case. So we could actually get the temperature differential between what the ambient temperature is and the internal device temperature. And that's where we kind of got that 17-degree figure, because we started with about, I think it's about a 4-degree figure, and through some of the tinkering and tightening tolerances and the active cooling fans, we're able to get that's what drove it down to that pretty much 17-degree difference figure. That really we saw it stabilize there, at, I think externals we saw upwards of nearly 120 degrees, inside of the car, but the device stood firm. It's still like 94 degrees Fahrenheit, which is pretty awesome. AJ, you do have a question in chat. Do you have any trouble passing the raw serial protocols through to the Docker container?
So the only real issue I had was getting the USB to connect through the Edge Hub into Docker, but that was more of a setting on the Edge Hub itself. There's a security setting, which was one of the things I had to work with the Splunk engineers to get sorted out, and we were able to make some changes on the back end of the Edge Hub to get that to work. And then as far as I guess interpreting the data that was coming out of the ECU, the Python library made all of that super simple. So just kind of follow the documentation on that, on what the on what to pull and how to interpret those into readable data, and all that part worked out pretty easy.
Yeah. Splunk has some fairly good documentation for the Edge Hub, specifically on what requires to run the Docker container, and how to kind of package it up. Another struggle we had, doing that data collection, is we recognized, that, tuned vehicles. So these are highly customized vehicles, but the tuners, the people doing the tuning of the performance of the vehicle, sometimes don't want you to interact with that or even view it or technically like steal their proprietary information. And so they'll actually lock people out. And so that limits the ability to actually read from OED. And so we were able to we had to basically get some flexibility in what software and what vehicles we're able to use, because of that limitation. Awesome. So this does say hands-on, but I do apologize due to some fun supply chain issues we had. These devices did not make it in the box. I will go over them though, and please either reach out to myself, AJ, or one of the staff from FCon after the event, and we have a process to be able to get these devices to you. But I will have this for the recording, so you kind of see. And I really wanted to be able to describe the parallels for people that may not be able to touch the Edge Hub or have interact with an Edge Hub for the next, couple months or something like that. I say that because they're at most of the Splunk conferences and roadshow things that you're able to maybe attend. So definitely keep an eye out if you're there. But I wanted to present a couple devices that you can definitely get your hands on. One of them about $20. The other one I think is between 50 and 60, that have some like functionality. So the first one I wanted to show you is called an M5 stick. There are different versions of this. I'm going to show you the 1.1 version. The one that hopefully we'll be able to get to you in the near future is this new M5 stick C, the +2 version. So it's a slightly different color, a little bit of an upgrade, but what this device is a very small ESP2 backed, I guess, modular device. So it has a very tiny screen on it, a small battery. It has IR, LED inside of it, a buzzer, buttons, and stuff like that. So it's pretty funny because you can actually use it to like control TVs and stuff. So it's one of those like TV turn off tools, which is pretty interesting. Some of the specifications over there on the side, again, these things are tiny. It's only like 48 millimeters wide. and weighs only 17 grams. So these things are about $20, like I mentioned. I guess you can hook up external sensors to them in addition to some of the built-in ones, very similar to the Edge Hub here. There's even a kit you can get that will turn it into a watch. We see this a lot in things like obviously STEM education and DIY projects because it's ESP32 has a very open framework and development community, so it's widely supported and fairly inexpensive from that aspect. So real quick, I'm going to show you what it looks like from a device setup. So here's the actual device. You can see the little screen. That is how big it is. Pinouts are all documented there. There's cables additionally that you can connect on the bottom for additional devices. M5 Stack, the company that produces this, does produce many different types of different sensors and things you can attach to it for, I guess, doing things like humidity. But let's see if I can actually play this thing again. If you look really, really carefully, you can see in addition to like the date and clock and battery and then LED and the brightness indicator and the sound indicator on it, right here is actually the gyroscope. So it does have a built-in gyroscope like the Splunk Edge Hub does. And so if you see, it's like a target kind of, and there's a red dot, and the red dot in relation to the target, almost like a bubble level, will show you how the device is oriented. So play this one more time. You can kind of check that out as he's moving it around there. You see it on the right side, that little red dot. He'll flip it over here in a second and show you the front. You can kind of see that as he taps it. Another kind of cool key aspect of this device, and I've got the orange older one here, is here you can kind of see a cube. And what the cube does is that's effectively, if this was a cube, you can kind of see it maybe not the best show and tell, but you can see it rotate as I move the device because it's, again, just kind of showing you in 3D the rotational telemetry it's getting from that gyroscopic sensor. It also has, again, that IR and everything on it, and again, the pinouts here. So really, really cool device. It's easy to grab from M5 Stack. And again, just please reach out after this if you'd like to get your hands on one from us. Another one to maybe look at that we used for some of the development of the Edge Hub, not specifically for this rally thing, but we did use it for some additional data points because of what it provides. It's called a Thingy 52. So it's this little device here, and it does come with a rubber cover that I've removed here so you can actually see the antenna and some of the internals. This is from Nordic Semiconductor. I think, and I have to check, I think this is around $60, $50 maybe now. This is like the M5 stick, except a little more developer focused. So a lot of the same sensors and stuff are built into this, but it does have like breakout boards inside of it and pinouts, so you can actually do more direct I guess, integrations with the device itself. It also has a Bluetooth chip, and specifically, Splunk has worked with us and provided some firmware so that this can be an external Bluetooth sensor for the Splunk Edge Hub, and it will actually integrate that because Splunk Edge Hub does support Bluetooth, and so you can actually connect Bluetooth sensors to it. This being one, and obviously since this provides a wealth of data from itself, is a good source. So you're not having, I guess, one-off individual sensors. We're able to do a bulk amount of development on this, things like light sensors and sound sensors, other humidity things as well from an environmental perspective. Great little product to test out if you're looking for something a little bit more advanced. It has its own IDE and developmental toolkit behind it, so definitely different than the ESP32 device. But yeah, had a lot of fun working with this. So again, that's a Nordic Semiconductor. It's called a Thingy 52. Also comes with a app for your phone. So you just Bluetooth to it and you can see all the data there, and it's got some fun graphs. So that's why it's a little bit more advanced than the M5 stick. Alrighty, so let me jump forward. So live demo time. So and crossed our fingers a little bit, but we've been testing this and done enough development that we think we're pretty solid here. But from an overview perspective, I wanted to cover a couple things, and Ajay will help me describe some of this from his experience. But this is how we were able to interpret, do some more development testing, and interact with not only drivers, but the actual rally engineers and trainers for the Rally Ready Driving School, the place that we're able to do some of this development at. So, I mean, kind of shout out and thanks to them. If you're near the Austin area, Rally Ready, great place, highly recommend it. But you can kind of see we graphed all this telemetry over time. Obviously, wanted to see how things would change, improvements. Um, some key indicators that we saw. So we're obviously tracking at the top things like the ambient temperature, humidity, the air quality, CO2, and this is the volatile organic compounds. At the top left, you can see this goes up to 1,000 parts per million. That is the maximum for the sensor. You can see the ramp up here. That's when we turned on the vehicle. So very, very quickly, that cabin was inundated with some pretty noxious fumes. But I guess that's just racing for you. We were getting things like the coolant temperature, intake temperature, throttle position, timing advance, the mass airflow sensor, the actual sound. I mean, that's obviously important. It's going to be loud, but if you have an Apple Watch, you know that high sounds can damage your hearing. So keeping that in mind is important. And then we mapped out the accelerometer and the gyroscope on the bottom. Key insights that we actually had from this, I guess above just being able to analyze data from run to run, is if you look down here, particularly on the image on the left, where I'm kind of highlighting here on the gyroscope, what this particular run was a training session based around what's called a slalom procedure. And what this slalom procedure does is teach you to shift the weight of the vehicle from one side to the other. Effectively, if you want to think you're going from a drift when you're turning right to a drift you're turning left, it gets you better to feel the weight of the car and transition the weight from one side to the other if you're doing turns and stuff like that. And so you're able to see as you go through one part of the slalom here, I guess one turn to the other turn. It may be a little hard to see with these colors. If you have the graph in front of you, blue versus green are the ones we would be looking at here. And from one to the next one, the blue and greens actually invert. So as green goes up, blue goes down, and vice versa. And this is really shifting from the right to the left. And working with the trainers over there at Rally Ready, what they let us know is that it was very interesting to them because they noticed like you could see if people were favoring one side or the other or effectively were more fluid from one side or the other. And they could actually use that to in their training from a data-driven approach to say, hey, we can see, the car moving and stuff like that, but they don't actually get the data behind what the weight transfer looks like at a very minute perspective. And this gave them some awesome insights into helping drivers, I guess, more adapt their skill based on direct data that we're pulling live. AJ, you have any other insights from this?
Yeah, I mean, in addition to the gyroscope, accelerometer, like the built-in sensors in the Edge Hub, it was interesting to kind of correlate that with things like the throttle position, so you can kind of see what the driver was doing if they were on the gas or off, how much they were letting off, or how much they were getting onto it, whether they were going from off to full open throttle or not. And then just kind of from a monitoring standpoint, you can kind of see what your temperatures are doing while you're out on track, or if you're like your oil pressures and things like that. Like if you're throwing the car really hard to one side and you're dropping oil pressure, you want to take a look at that and try and stop that from happening, because that's how you grenade engines, and that's when things start to get really expensive. So using this dashboard, we can kind of monitor things like that. And then just over time, keeping track of coolant and oil temperatures as well, because sometimes when you're driving, you almost get that red mist and you're kind of just focusing on what's in front of you. You don't really look at everything else that's happening. So you might not notice if your car's starting to overheat or whatever. So something like this is going to kind of show you, okay, well, the car was getting hot here in this section, or and then it was cooling back down. And so you can, if whoever's monitoring that data in the pits can radio into the driver and be like, hey, come in, you're going to kill the car, kind of thing. But it was interesting to kind of see everything laid out in one place, because a lot of the times, when you're in the car, you only have your basic gauges, like maybe an aftermarket temperature gauge or two, and then your tach and speedometer. So having all this laid out is nice to kind of go back and analyze and run back through everything just to kind of help you improve for the next run.
Absolutely. Okay, so I'm going to pivot really quick and show a live dashboard we have. Let's make sure I'm pulling the right one. So this is kind of the next evolution that we're getting into when we're starting to adapt some of the dashboard. This is still kind of a little bit in draft mode. The data may not be accurate because we don't have this actively connected to a car. I'm going to go through that in a little bit in a minute. But what I did want to show you is how we can take what we did before and take it to the next level. So we have the same sort of metrics driven at the top between temperatures, humidity, and air quality, and also down to engine load, speed, and RPM, all the same data points that we showed you from the previous screens. But what we're also able to add now is on this very, very far right side, this is I guess it is a map. In this instance, this is the Las Vegas street circuit. Familiar with F1? They had an F1 race out there. And so we're able to get the live geolocation, or at least in this demo we are, of the vehicle itself. And so that really pairs up what our data is with where they are in real life, because some tracks you actually can get full view of the full operations, but some obviously they're going to go out of view. And so knowing the location and being able to pair that up with what's going on from a data perspective is important about braking into turns, accelerating out of them, what the G forces and everything look like in turns, especially, or for acceleration. And so you can kind of see the car actually driving around the circuit here. I might be able to zoom in a little bit more. But you can actually, it kind of traces its path and leaves a little tail here as it goes down the strip, back and around, through and outside the pits. So again, just kind of tailing on to what we previously done, adding that additional data set feature of geolocation, which we can get through things like the cellular GPS from the Edge Hub itself. All right, let me pivot right back over to slides. There we are. All right. So I went over those. I showed you the Las Vegas street circuit demo that we have, but moving on to, I guess, future and development. So obviously we're looking into things like how can we not only improve the performance of the code and telemetry that we're writing, but also the performance of the drivers and race teams. Some of the lessons learned we've gone over a little bit in terms of how we do heat management and how we can maybe adapt, or I guess take some lesson learned from the placement of devices and how we can actually best bolt it into vehicles. And I think one of the things we found is possibly having something like a tubular mount, because a lot of these cars have roll cages. That's a common feature, and if we can take advantage of a common feature, we know that there's a 12-volt, I guess, power plane throughout the car. A lot of doing this, I guess, not plugging into that was we didn't want to mess with anything on the car, especially in vehicles that we were testing into. So that was important to us. AJ, any insights into maybe some potential performance improvements that motorsports teams can, I guess, in rally or drift or anything else can expect from, I guess, looking at some of this data?
Yeah, I mean, overall, like just generally being able to keep a better eye on the car mechanically, keeping an eye on temps and things like that, temps and pressures, just to make sure that the car is in good working condition, and even like stuff like battery voltage. I mean, if your battery's starting to die, you can kind of address that before it's completely dead and you get stuck in the hot pit and have to push your car all the way back to change it out. Um, so overall, just monitoring in general, it's a big thing. When you're out on the track, when you have a driver in the car, you don't know what's going on with it. You don't know how close of an eye your driver is paying to the car and to the gauges that you do give them. So being able to get that data in real time back in the pits and being able to yell at them when things are going wrong will be a huge help, especially in things like endurance racing or just racing in general.
Yeah, nope, absolutely good points. And uh, this target, I guess, for motorsports is really focused in on not obviously not F1 teams with billion-dollar budgets that are able to custom develop gram pieces of hardware at very low weights to be able to put into their vehicles, but teams and racing drivers like yourself that um, want something that's easy, flexible, can put into different cars and almost create like I guess a pit in a box type of thing you can have on the side and maybe have a buddy way into or a smaller racing team that's able to just, have this kind of integrated into their platform and still get those insights on the side without a massive R&D development or R&D budget. So there's obviously other motorsports this goes into. AJ talked a little bit about his experience with drifting and stuff, but it kind of goes across the board through any sort of vehicle or obviously into things like the logistics perspective that may not be racing oriented, but are still vehicle specific and have the same sort of insights, implications, and issues for just vehicle traveling for long amounts of time and still needing to maintain the health of the vehicle and the driver itself. I guess moving on to some enhancements. Uh, we have ideas for code and the GPS, so we kind of noted here as well. What we also want to do is be able to break into additional capabilities that different vehicle platforms have. So most basic, I guess I say basic, but most vehicles have interaction at the OBD protocol. There's also a protocol called CAN bus, which you may be familiar with, which is a different protocol in the same stack in a vehicle computer perspective. So that's kind of our next goal is to be able to interact with the CAN bus protocol, and we've got that kind of planned out in a couple different methods. One, going back to lessons learned, we realized that it's fairly difficult to, I guess, get out to a track consistently, especially on a development cycle and I guess remote as we both are. So being able to have a remote development platform would be beneficial for pushing this thing forward, being able to do testing and validation of different technologies. And so one thing we honed in on is a technology published from Toyota Motors called Ramen. At least that's what we've been calling it, RAMN. And so what this is a pseudo open source hardware and software platform that enables you to have four legitimate car ECUs and a CAN bus ecosystem in the palm of your hand. And so this actually allows you to have things like I guess what are these like the body, throttle, powertrain, as well as something like an infotainment system. And so you can see like this is a little screen here that mimics an infotainment system ECU. You've got most of the, I guess, body peripherals here, so you can see things like obviously the key, your blinkers, flashers, engine lights, hazard lights, and issue lights on the top right. And this bottom thing, you actually have a brake and accelerometer, so I guess your brake and your gas pedal, as well as a shift button for gears. And then this left side is lighting, so almost mimicking either lights on the stalk of your vehicle and then a steering wheel as well. And so this is a fairly custom hardware platform. You actually have to send out the PCB specifications, get those printed, get every piece of every electronic component individually, build the boards yourself, and then flash all the ECUs there. So it is a little bit labor intensive, but it's like the only thing that we found that actually supports a full CAN output via this little green terminal here. You can also interact via USB, but it mimics, an actual vehicle without having to, spend, tens of thousands of dollars on one and have it sitting in my office. And so here's the one that we've built, and that's literally how big it is in the palm of your hand. It is modular, and so each of these four I guess modules actually pop in and out of each the CPU components here. You can kind of see with the little risers here. So you can go check it out. It's on GitHub. All of the specs are there. You can send it out We use JLC PCB to print these for us and turn out really, really great. Definitely reach out to us. We have some fairly technical lessons learned with building this thing. Kind of, too much detail to go into in this talk, but happy to kind of take it offline or part of the Q&A afterwards. And on the right side of this is, for those that aren't familiar, kind of how the CAN bus is integrated into vehicles from your dashboard. Effectively, think about it, it's multiple different computers spread out across your vehicle that control different portions of your vehicle, but work together to kind of make everything run in sync. AJ, anything I missed from either of those?
No, I think you pretty much covered it.
Awesome, thank you. Well, without further ado, I want to open up a little bit for any Q&A people may have. Let me check the queue, see if anybody has anything, or feel free to just pop open your mic and let's have a chat. We all are quiet today.
Hey guys, this is Tom.
Oh, hi,
That
Tom.
was super cool. I've always wanted to learn how to drive a rally car, so it's super neat to see that tie in. Um, so I am kind of curious. So you mentioned earlier that you guys weren't able to get stuff out to everybody. So I guess like what should I look for in my kit if I did happen to get the things I need to put this together?
Sure. So for this, the device that we had spec'd out was this M5 stick. So it's probably not going to be in your kit, but this is one of those like, please reach out to us afterwards. We're going to range through people in different areas, but obviously if you're dialing in, just reach out to us, and we're just waiting for them to get, and just fun supply chain issues as part of doing these kind of things. So that's the device itself, or feel free to just go out and grab one because they're fairly inexpensive. But that's the idea there.
Yeah,
Very
so
cool. And sorry,
as
go ahead.
John, oh no, sorry, as John mentioned, yeah, we had these coming in from China and had some issues with shipping. Obviously, overseas is always fun, but once we do actually get them in, what we'll do is we'll send a note to all of the registrants, and if you would still like to get one, we'll, like I said, figure out how to get it to you. But yeah, we're still awaiting their arrival.
Okay, awesome. And then I assume you guys are going to post like a how-to guide and all that to run through how we build everything out.
So I guess to be specific, so the solution that we've built for the rally thing specifically was built around the Splunk Edge Hub. So that's not something that's like it is readily available from like a corporate purchase perspective. It's not really something you can go out to Best Buy and purchase. What we wanted to do with this kind of analogous device here is show that there are different things out there that will be able to grab telemetry, environmental factors, and allow you to play with that data. So there's not really anything we can publish on that front, but if you want to, deeper conversation about Edge Hub, potentially getting your hands on or something like that, we can probably, definitely reach out after after this talk.
Oh, sure. Sorry, I guess that me being vague. I assumed kind of for the M5 stick that you guys had like a planned like little walkthrough or something like that. Make lights blink, that kind of
Oh,
stuff.
yeah, no, so yeah, great question. So, and apologies for kind of, I guess, glazing over that. This device is something that you just turn on and it kind of works. It has a couple screens you can click through in terms of telemetry and stuff like that, but it's all self-contained. There's really no setup to it. That this little minor video is literally the setup. You just turn it on and all the sensors are right there for you.
Oh, awesome. Cool. Thank you.
Yeah, yeah, absolutely. No hardware flashing, code, IDEs, or anything like that. It's just there for you. That's why I kind of honed in on this. It's just an easy button. See, a couple other questions. What additional pieces of info do you wish you had on that dashboard? AJ, I think you can probably cover that better
So
than I can.
yeah, so a couple of more pieces of data that would be nice to have on a dashboard would be stuff like tire temperature and like brake temperatures. Those aren't necessarily things that come through OE2 or even CAN bus, but just those two pieces of information would be huge from a racing perspective. And then just overall, just the general diagnostics of the car, like the temperatures of like all your fluids and the pressures of all your fluids that require high pressures to run. one of the limitations that I'd figured out, I think I forgot to mention it earlier, was that not every ECU actually tracks every single value. So I found some differences between like what I was able to pull from my M3 ECU versus what we were able to pull from the Subaru ECU. And so kind of just going through and figuring that out, um, it was it was kind of a little bit of a hurdle to get over. And then I don't know, did you want anything to that, John?
No, I mean, we pretty much covered. I mean, with the insights we had, obviously tire temperature for a lot of racing, but from a rally perspective, brake temperature is more important to them. Most vehicles don't actually have that sensor built in. The ones that we found are, it's kind of one-time use. It's a probe built into the brake pad with some manual wiring we have to do. So that's kind of on our radar as a potential solution for that kind of a known problem, because insights into brake temperatures for them, because they're braking constantly to actually modify the I guess a translation of the vehicle. And then I think that's mainly it. And then yeah, like you mentioned, diagnostics and stuff like that. A couple other questions is here. John Washburn asked, was a polling interval rate 1 second intervals for all the stuff that we did?
Yeah, that was
So
the
also-
question. Is it also the same as is that the independent of the resolution, or the resolution of the data also 1 second polling interval? In other words, you're collecting the data at 1 second interval, but what about the resolution of data like accelerometer data?
Good question, AJ. You got that one?
Sorry, what was the question again? I was replying to someone in chat.
He's asking about the resolution of the data versus our polling intervals. So I'm assuming it's something akin to
Oh.
what, availability versus collection.
Yeah. So the poll, to answer that other question, the polling rate was like 1 event per second. But the car is generating way more data than that. So we are kind of missing out on some data there. But we're kind of getting the general timeline of everything as much as we actually can. So it's not, 100% perfect, but it's better than nothing.
So is it
Yeah.
an issue of bandwidth, or can each attribute have a resolution independent of each other?
Yeah, it's basically an issue of the bandwidth from OBD2. I believe you could pull data faster from CAN bus. I'm still kind of playing around with that. But yeah, it was definitely a bandwidth limitation through the OBD2 protocol.
Yeah, and a little bit of it is the receiving protocol from a sensor perspective with MQTT it was better for us to have a static polling interval for all of the sensors, so we could wrap it up into a single event and send it to the MQTT broker, as opposed to breaking that up and adding more overhead to the MQTT broker, because in a platform like this, it's there are limitations to that. I don't think we came anywhere close to that, but we did want to make sure that that wasn't going to be a hindrance to our development. One other thing I think I forgot to mention a second ago when you're talking about, extra data, and you mentioned things that were missing. One thing we did notice is that, like AJ said, with like the throttle itself, some of the cars have hardware throttles that are not integrated into the computer system and the ECUs. And so if you're reliant on that, that's just a piece of data that we weren't able to capture from those vehicles, because it was not a digital attribute of the ECU.
Is Fulcrum looking into pulling this type of data off of other types of cars, like F1 trucks, other vehicles, boats, maybe, or something?
Yes, anything we can possibly get our hands on. F1 may be a little bit out of our reach from some compliance and intellectual property perspectives, but there are many motorsport, teams in between day to day weekend warrior and those teams that we're definitely kind of ingrained in. Rally Ready's kind of one of those, because Red Bull team does practice out there, and so we're able to use their vehicles. I hinted a little bit, we have a lot on the if you want to call it like a logistics side, where it is things that are not racing oriented, but still have vehicles like trucks, trailers, things like that that don't have that their goals and value are not winning races. It's delivering products to consumers. And so you can take the same sort of insights to ensure the health and safety and efficiency of the vehicle in their goals from point A to point B, and here start to finish line, but the places it's farm to factory. Bo said maybe in UAVs. I actually have a bunch of buddies in this space. The device I think is 470 grams, so it's that's almost akin to like why it's probably not suited for things like specialty implementations like F1, because those very much have they're very specific for gram by gram savings of weights, especially if you're going to fly a car and fly a UAV. But cars, I mean, there's many studies that talk about only a couple pounds equating to literal seconds of time around a racetrack. And so if you're a little less caring about that, this is a great R&D product and potentially production product to be able to actually enable that, or at least give you some insights into what you should be more cared about. Any last questions? Awesome. Well, again, thanks everybody. I think this is a great talk, at least for us to give it, and a lot of great experiences. We had a lot of fun developing the solution. Feel free to reach out afterwards if you have any additional questions or want to see anything else. AJ and I certainly love talking about this. But no, thanks for coming to DEF CON. Thanks for coming to this talk, and we'll see you at the next one.
Thanks all.
Thanks, John and AJ. Great presentation. Appreciate it.
Thanks, Heather.